Hello everyone, it's Wilson here. Today let's talk about solving exponential equations. In this video, I'm going to show you 5 different examples for solving exponential equations, and each one will show you different details of dealing with different situations when we are solving this kind of equations. Okay, so we are going to start with the first one, 9 to the x equals 27. The idea is that usually we try to get both sides with the same base and so that we can match their exponents, so that if possible. Okay, so sometimes it may not be possible, then we need to use a different method to solve the equation. But as you can see that 9 is a power of 3 and then 27 is also a power of 3, so we can actually turn both sides into the same base. So what we can do is that we can turn the 9 as 3 squared, and then we have the x. And then what about the 27? 27 is actually 3 to the third power. So we can actually have this into the same base now, but that's not ready yet. We still need to deal with the inside exponent and then the outside exponent. So we can, what do we do with them? We actually need to multiply those two together. So we are going to get 3 to the 2x. That is equal to 3 to the third power. And as you can see that this 2x and then the 3, we can actually set them equal to each other because now they have the same base and the two numbers from both sides are the same. So that means their exponents must also be equal. So what we are going to do is that we are going to get 2x is equal to 3. And so now we can solve this equation for x. So we get x equals, divide both sides by 2, so we get 3 over 2. And so that is the solution to this equation. Next, we are going to see another example. Okay, so here is another example, and we are going to practice that same idea as the previous example. What we're going to do is that we try to get both sides so that they have the same base, and it just happens that it's also possible for this equation. Why? Because we have the 4 here, we have the 8 here as the basis, right? And the 4 is actually a power of 2, and then the 8 is also a power of 2. So we can actually turn both into the same base with the power of 2. So now what we can do is that we can turn the 4 into 2 squared, and then we still have the 2x minus 3 on the outside. And then what about this one? This one is the same thing. So we are going to get 2 to the third power, okay, just like the previous example. And then we still have the outside power, there was the x. And so now there is the inner power, there is the outside power. We can multiply them together. So we are going to get 2 to the 2 times 2x, we get 4x. And then 2 times -3, we get -6. And then here we just get 2 to the 3x. And so now, just like the previous example, this part right here, this exponent here and this exponent, they must be equal to each other. Why? Because their bases are the same and the two sides are equal, right? So we can say we have 4x minus 6 is equal to 3x. This one is slightly more complicated than the previous example, but it's still quite really simple, right? So all we need to do is to get the x by itself, so we can subtract the 3x from both sides. So we are going to get 4, actually we'll just get x, okay, 4x minus 3x, and then move the 6 over. We are adding the 6 to both sides. Actually, if you want to see the details, then I can do minus 3x, so minus 3x, and then we can also do the plus 6, and then plus 6. So now we have 4x minus 3x, we get x. Those two will get cancelled, -6 plus 6, right? And then those two will also get cancelled, so we are left with just x being the answer. Okay, so that's the, if you want to check the answer, you can plug it back into the equation, and then just to make sure that the x equals 6 will satisfy the equation. We'll continue with another more complicated example. Okay, so we are going to see a more difficult one, but we are going to continue to practice the same idea. So we try to get the same base on both sides, but this time we have a fraction on the side with the numerator and the denominator both having an exponential function. And then you may say, what should we do? There are different ways that you can handle this. We can actually multiply both sides by this denominator, and then so that we don't have fraction on this side anymore, or we can simply just deal with this. And what we can do is that we can turn all of them into the base 5, because you can also have you can turn the 125 into 5 to the third power. Okay, so just to make a note here, is that just keep in mind that 125 is a power of 5, which is 5 to the third power. And then 25, of course, would also be a power of 5. It's 5 to the second power. Okay, so what we can do now is that we are going to turn this 125 into 5 to the third power. So we are going to get 5 to the x at the top. Okay, and then in the denominator, what do we get here? We are going to get 5 to the third power. And then the outside has 3x plus 1. And then that's equal to 25. 25, we also want to turn it, so we get 5 to the second power. Okay, so far so good. Now the next step is that we are going to multiply the inner power and the outside power together, right? So we are going to get 5 to the x. And then we are going to get 5. And then here it's 3 times 3x, so we get 9x plus 3 times 1, so we get 3. And 5 squared on the other side. Okay, now you may say, what should we do with this over here, right? What happens is that we have 5 to the x and then 5 to 9x plus 3. And then you may say, how do we simplify this? Well, let's just recall something over here. Let's just recall is that according to the rules of exponents, if you have, let's say if you have a to some power m over a to some other power n, and they have the same base, right? And so what happens is that we have a to the, we use the top power and then minus the bottom power. And then of course, this is assuming that a is non-zero. Okay, so we can do the same thing here because the a, in this case, is the 5, right? And then we have the m is the x, and then the n is the 9x plus 3. So now what happens is that we are going to do 5, and then now the top power, which is this m over here. So you can actually see that that's x, okay? And then this one is 9x plus 3. Okay, so we do the subtraction. So m first, which is x, and then minus, and then n, so 9x plus 3. Now, it's not correct to just write it like this because we are doing the subtraction and there are more than one term over here. So make sure that we put parentheses around the 9x plus 3. And then now what about the other side? The other side, just leave it, so 5 squared. Okay, so let's keep going. Now we can simplify this exponent first. So we are going to get 5 to the x minus 9x, which will give us what? Well, let's just write it down, and then minus 3 is equal to 5 squared. And then just keep going. So continue to simplify. So we get negative 8x minus 3 is equal to 5 squared. Okay, so what happens is that we can now, just like before, set the two exponents equal to each other. So we get negative 8x minus 3 is equal to 2. And so now we can isolate the x. So we add the 3 to both sides of the equation. And then we are going to get negative 8x is equal to 2 plus 3 is 5. And then we just need to do what? Divide both sides by negative 8. And then we are going to, those two will get canceled. So we're left with just x. What do we get here? We get negative 5 over 8 as the final answer. And so that's it for this example. And then we are going to try more examples because there are 5 examples in this video. So next one, we are going to actually run into a situation when we cannot really turn both sides into the same base. And then let's see what happens. Now let's do the 4th example. This one, it's the one that we cannot really turn both sides into the same base because we have a 3 here as the base and the other one is a power of 2. So we'll not be able to do that. And then now what should we do? There are different ways that we can do it. So I'm going to show you more than one approach in this example. So first one, let me just write this down. So approach 1. Okay, so all we need to do is that we are going to just change into the logarithmic form for this equation. This is, you can think of this equation in the exponential form. Okay, so now let's just remind ourselves what's going on. Okay, so let me just put down something over here. Okay, so when we have a log equation, so let me put the base over here, and then there is a, let me put a capital A here, and then we can put k on this side. So actually it doesn't matter. They're just labels, right? So it's up to you how you want to do this. So if you have an equation in the log form, we can actually turn it into the exponential form. Okay, so how do we write it? The base is the base. And then this k here on the other side is the exponent. And then what do we get here for the argument of the log? So we just get the capital A over here. Now, what happens is that we have an equation in this form and we can actually turn it into a log. So what we can do, okay, is that we are going to just write down the log, okay? And then the base is actually our base over here. So we put the 3 and then the exponent, it's going to be isolated. And then the other side is the what we put inside the log function. So now what should we put inside the log function? The number 8 is going to be put inside the log function, and then we are going to get the k is the exponent, and in this case the k is the x, right? So we just get x. And if you want to just rewrite it, so you can write x is equal to log to the base 3 of 8. And so we isolated the x, and that is our answer for this equation, okay? And then now let's try a different approach. Here's another approach that we can find the answer. So, okay, so now you may say, what should we do? Okay, so we have the two sides, right? And then if the two sides are equal, that means we can also have the ln of 3 to the x also equal to ln of 8, because the 3 to the x is equal to 8, okay? And so I should put parentheses so that it will look better. It's easier to see. So now it looks like this, okay? And then now what should we do? We can use a log property that will allow us to bring this x down to the front, okay? And so now it becomes what? It becomes x, and then we have the ln of 3, and then that's equal to ln of 8. Okay, so now we have this. ln of 3 is a number and ln of 8 is a number. And what we can do is to isolate the x. And how should we isolate the x? We can simply just divide both sides by the ln of 3. Okay, so we divide both sides by ln of 3. And you can see that we can actually just cancel them, right? So we are going to just get x on the left side. And then what do we get here? We just get ln of 8 over ln of 3. And now, you may say the two approaches are not giving us the same answer. In fact, they're actually equivalent. They just look different. This one is natural log, so the base is e. And this one is log to the base 3. And there was another formula that we should recall over here. So let's just recall another formula. Okay. There was the base change formula that we can recall. So we have, let's say we put a b here and then we put the a over here, okay? And then we can actually change the base from base b to another base. In this case, we actually want to change it to the base e, so we use natural log. So we can actually write natural log of a, okay, over, and then natural log of the base b. Okay, so the argument of this log function goes on top and then the base goes right here. Now, if we do the base change from the approach 1, you see what's going on here? We can actually write ln of the number 8 over and then the ln of 3, which will be the same answer as this. Okay? Okay, last example here, as you can see that this one is more complicated than the previous one, and also you can see that we cannot turn both sides into the same base because the base here is 4, which is a power of 2, and then the base here is 5, right? So there is no way that we can turn them into the same base, but it doesn't matter. We can actually just use the approach 2 that we have in the previous example to start solving this equation. So we are going to start writing it this way. So 4x plus 3, and then we have what is the right hand side is 5 to the 2x. And then because the two sides are equal, so that means we can do the ln. And so as you can see that the ln of each side, okay, and then the two sides will still be equal. And then now what happens is that we can bring the exponents, so this one, the exponents is being brought to the front, and then same thing over here. So we gotta bring that exponent to the front. When we bring this x plus 3 to the front, we need to be a little bit careful. When we write it x plus 3 and then L1 this will not be correct, because even if we put a dot here, because there are more than one term, it's not okay to just put x plus 3 and then times L1 because we have the L1 must be multiplied to both x plus the x and the 3, not just the 3. This one right now, it's showing that only the 3 is being multiplied by the L1, not the x. So we need the parentheses. Okay, so now this is a lot better. And so now what do we have here? This one is okay because this one, we don't need the parentheses because there is only one term. So we have the 2x and then L1. Okay, so that's ready, and we are ready to start solving the equation for the x. And then you may say, what should we do? Here is what we do. We can distribute the L1 to both the x and 3 here. So we are going to get x and then L1 plus 3 L1, and it's equal to, well, this one we just leave it. That will be 2x L1. Okay, it looks like a total mess because of all those natural log functions, but it's okay. But L1 is really just a number. L1, L1, they're all just numbers. Okay, so now our goal here, remember, is to solve for x, right? So we just need to remind ourselves which term will have the x. This first term has the x in it. This term also has the x in it, so we actually need to get them on one side. And then the term without the x, this term does not have the x in it, so we are going to get it to the other side. Okay, so we are going to subtract both sides, subtract this from both sides. So we are going to get x L1, and then minus this thing. So we have 2x L1 is equal to, now this one should be isolated on the other side because it doesn't have an x in it. So we are going to get -3 and then L1. Okay, so now let's continue with solving this equation. At this point, it looks really confusing because of all those things, right? But it's okay. So what we need is really just to get the x by itself. And so that means we need to factor out the x. Don't try to factor out other stuff, just factor out the x. And so as you can see that if we pull out the x, then we are left with L1. And then, well, let's just show the highlight over here, then it's easier to see. So L1 is what's left. And then when we factor out the x from here, the 2 is the L1 will be left. And then of course, don't forget the minus sign, right? So we have minus, and then we have 2 L1, and then we have the right hand side of the equation. And then all we need to do, because this is really just one single number, you can actually just think of this as what? As just x times some other number. Let me just pick a number over here. Let's say m is equal to n, for example, right? And then you know how to solve this equation. You just need to get the x by itself by dividing both sides by m. Okay, and then what happens? We get x is equal to m over n. It's that simple. So now it's really just the same thing, and you just think of this as m, and then the other side as the n. Okay, so now what happens is that we are going to get x is equal to now this, -3 L1, and then all over this stuff, because this stuff is the m over here, as you can see. So we have L1 minus 2 L1, and that is our final answer. Okay, so that's it for all these examples. We will do more videos on solving different kinds of equations next time. Thank you for watching.